Hello everyone, welcome to another topic in the basic concept of X-ray. Today we are going to read about the exposure factors. Exposure factor, kilovolt peak and milliampere second. And another topic we are going to read today is Compton and photoelectric effect. These two topics we are going to read today. We are going to discuss today in detail. So let us start with the exposure factor. The exposure factor, kilovolt peak and milliampere second. And these two exposure factor really determines the penetrating power of the X-rays and the contrast of the X-rays. So what I mean, the kilovolt peak. The kilovolt peak is the voltage applied across the cathode and anode in the X-ray tube. The higher the voltage, the higher the kinetic energy of the electrons hitting the anode. So the greater is the penetrating power of the emitting rays. So the higher the voltage, the higher the kinetic energy, and penetrating power is also higher. So the voltage applied across the cathode and anode is directly proportional to the kinetic energy of that photon striking the anode and directly proportional to the penetrating power of the X-rays. Kilovolt ampere is directly proportional to the penetrating power of the X-rays. So the kilovolt peak also affects the radiographic contrast. So the kilovolt peak is inversely proportional to the radiographic contrast. The higher the kilovolt peak, the lower the contrast. Whereas if the kilovolt peak is low, then the contrast is high. So if there is low kilovolt peak, then there is high contrast, and it is also known as short scale contrast. And if there is high kilovolt peak, there will be low contrast, and it is called as long scale contrast. So let us move toward the milliampere second. The milliampere second. The milliampere second is the combination of the milliampere, the current passed through the cathode filament. The current passed through the cathode filament, milliampere, and combination of the time of exposure. It determines the number of X-rays photons. The milliampere second determines the number of the X-ray photons in the X-ray beam. It also affects the density and blackening of the film. And the milliampere second is directly proportional to the contrast of the X-ray film. It means if the milliampere second is increased, there will be the increased contrast. So through this topic, what we learned that the kilovolt peak and milliampere second is the kilovolt peak and milliampere second directly affect the contrast of the X-ray film, and the kilovolt peak is directly proportional to the penetrating power of the X-rays, whereas the milliampere second is proportional to the number of X-rays photon in the X-ray beam. So these are the two very important topics you should know. So now let us move toward the Compton effect and photoelectric effect. Now let us discuss the interaction of X-rays with the matter in the human body. What happens in the patient body when an X-ray beam enters in our body? So there are ways in which X-ray beam interacts with the patient body when they enter inside. The various interaction is known as one is Compton effect and another is the photoelectric effect. These are the two effects that occur inside the human body when the X-ray enter inside the human body. So let us discuss about the Compton effect. So Compton effect, it describes the interaction of the X-ray photon with the outer cell electron. The Compton effect describes the interaction of the X-ray photon with the outer cell electron. What happens is that the X-ray photon enters the patient body, and then it collides with the outer cell electron of an atom, which is loosely bound by the nucleus, because it is the farther away from the nucleus. Because the electron is loosely bound, only a small amount of energy of the X-ray photon is transferred to the electron, and it is thrown out of the atom. The electron is thrown out from the atom. Here you can see. the incident X-ray photon still has energy left, so it travels ahead, but with the change of the direction. If it is traveling, it should go like this in this direction, but due to the collision, it changes its direction in here. So what happens? Due to the change of collision, the deviated X-ray photon constitute the scattered radiation. The radiation is scattered. So always we try to minimize the Compton effect. It is the most common interaction of the X-rays with the matter. It is the mid-energy phenomena. The most important outcome is the scattered radiation in the Compton effect. It causes image distortion, blurring, and decreased diagnostic quality of the radiographic image. So we try to minimize the Compton effect. So how we minimize the Compton effect? We use high energy X-rays. So now let's discuss about the photoelectric effect. The photoelectric effect describes the interaction of X-rays photon with the inner cell electron. It describes the interaction of X-ray photon with inner cell electron. What happens? The X-ray photon enters in the patient body. So it collides with the inner cell electron of an atom. It is tightly bound by the nucleus because it is nearer to the nucleus. Because the energy is tightly bound to the nucleus, entire energy of the X-rays photon is transferred to the electron and is thrown out of the atom. The electron void in the innermost cell, because the emptiness is created because one electron is thrown out of an atom. The electron void in the innermost cell is filled by the jumping of the outer cell electron to the inner cell. So the incident X-ray photon is lost. This photon is lost, and there will be the no scattering of the radiation. So it is the less common phenomena. It is the low energy phenomena, and there is no scattered radiation. So the image quality is better in the photoelectric effect. So we try to maximize the photoelectric effect because the image quality is very good in the photoelectric effect. So we maximize the photoelectric. How? We use the low energy X-rays. And high atomic number target. So this is the explanation of the Compton effect and photoelectric effect that you should know very detailed in the basic concept of X-rays. Thank you.